Hello everyone, let's look at this power series here. We are going to find the radius of convergence and the interval convergence for the series, and we are going to use a ratio test for this. The ratio test actually can tell us when the series is convergent and when it's divergent. And so in this case, the ratio test will actually allow us to find out for what x values is the series will be convergent. And so let's get started. First, we are going to have this expression, right, which is the a sub n, right? So that's our usual expression right here. So that's our -1 to the n times x plus 3 to the n. And then in the denominator, we have n to the 2 over 3 and then times 2 to the n. And then for the a sub n plus 1, okay, so just our usual setup right here, a sub n plus 1, that's equal to -1 to the n plus 1, right? So we're replacing all the n values by n plus 1. So we are going to get x plus 3 to the n plus 1. And so we are replacing it by, so that one is also n plus 1 raised to the 2 over 3 power times 2 to the n plus 1. Okay, so if we simplify this a sub n plus 1 a little bit, then we are going to get -1 to the n plus 1 here. And then x plus 3 to the n times x plus 1, plus 3 to the first. And then we are going to get, what do we get at the bottom? We get n plus 1 to the 2 over 3 times 2 to the n times 2 to the first. Okay, yeah, so usually we can try breaking things up so that when we actually put them together, we can do the canceling really quickly. So now let's actually start getting into the ratio test. So for the ratio test, we are going to take the limit as n approaches infinity. And then we are going to put down just the a sub n plus 1 first, which is this expression right here. So we are getting -1 to the n plus 1. And then we have the x plus 3 to the n. Oops, I forgot to close the parentheses. And then we get x plus 3. Okay. And then we are going to get the denominator, which is n plus 1 to the 2 over 3. And then times 2 to the n times 2. Now, times, what do we get here? We are going to get the reciprocal of this expression right here because we're taking the a sub n plus 1 to divide by the a sub n, right? So when we change it to multiplication, instead of writing it as a complex fraction, we can simply just take the reciprocal of this expression, which becomes n to the 2 over 3. Now the denominator becomes the numerator. We get 2 to the n at the top. And then in the denominator, we get -1 to the n. Just realize that I was using the line too, so that's why it looks strange when I was drawing. Okay, so we have also the x plus 3 to the n. Yeah, and then we take the absolute value, right? Yeah. So now if we, let's start doing the calculation right here. So there are a lot of things that can get canceled. We have the x plus 3 to the n and x plus 3 to the n. Those will get canceled. And then we are going to get 2 to the n, 2 to the n will get canceled. And then I think that's it, right? And also, I should just mention one more thing right here, which is that the -1 to the n and the -1 to the n plus 1, when you cancel them, you are just going to get a -1 inside the absolute value. But once we take the absolute value, that -1 will go away, right? So we actually don't need to worry about the alternating factor or the -1 anymore when we take the ratio test. So in this case, we only would be writing down the stuff that's left without the -1. So the limit actually becomes um, actually becomes what? Let me see. In the numerator, we do have that x plus 3. And then the n to the 2 over 3. That's all that stuff that's there. And then at the bottom, we are getting the 2 and then the n plus 1 to the 2 over 3. Okay, so that's just all that. And then, so you know that the x plus 3 does not depend on n. And so we can actually move it outside the limit, and then same thing with the 2. And in that case, it will actually look like this. So we have the 1 over 2, the absolute value of x plus 3. Now, because x can be a number, that will cause the x plus 3 to be a negative, so we need to keep the absolute value. And then now we have the limit that's left, which is just the rest of the stuff. So if we take the 1/2 outside and then the x plus 3 outside, then we are left with just the n to the 2 over 3 and n plus 1 to the 2 over 3. Because they have the same exponent, we can actually just put them as n over n plus 1, the whole thing raised to the 2 over 3 power. And because when n is approaching infinity, the stuff inside the parentheses is approaching 1. And then 1 raised to that 2 over 3 power, that's still, the limit is still just 1. So we have that expression, which is just 1/2 times x plus 3. And then times the 1. So that's just that expression that we have. Okay, now the ratio test tells us that if the limit is less than 1, then the series is convergent. And so because we are finding the radius of convergence, so we need to look at this limit right here. And we say that when 1 over 2 times absolute value x plus 3 is less than 1, that's the result for the ratio test, right? So that's what the ratio test is telling us, that when this limit, right, is less than 1, then we know that the series is convergent. And so we have x plus 3 is less than 2. And this actually tells us the interval. What is the interval right here? We can solve this inequality, right? Actually, I should say now, right, instead of so. And then if we're solving the inequality, then we are going to get what? Let's just do a little bit of calculation right here. We have x plus 3 less than 2, greater than negative 2. And then if we subtract 3 from all 3 parts, then we are going to get what? We are going to get, subtract the 3, negative 5 less than x less than subtract the 3, yeah, negative 1. Okay, so that will give us the interval. And the problem is this. We actually have no information about um, the negative 5 and what happens when x is equal to negative 5 and when x is equal to negative 1. Because that's when x is equal to negative 5. Let's just go back to this inequality and see what happens. Let's look at the limit. When x is equal to negative 5, then let's just do some calculation here. So 1/2 times negative 5 plus 3. So let's just do the calculation right here. We have 1/2 times the absolute value of negative 5 plus 3 is going to be negative 2. But when we take the absolute value, we are going to get positive 2. So it's 1/2 times 2. So we are going to get 1. And then same thing for the case when we plug in the negative 1 in there. So when x is equal to negative 1, and then you plug it back into this limit, then we are going to get 1 over 2 times 2, right? 3 minus 1. And then that's actually just 1/2 times 2, which is still equal to 1. We actually have no information from the ratio test when the limit is equal to 1. The series can either converge or diverge depending on the situation. So what can we say about when x is equal about the series when x is equal to -5 and -1? We actually need to plug those two numbers back into the original series and then try to test for uh, whether it's convergent or divergent. Okay, so let's try that. And then we'll write down all the information that we need for this problem. Okay, so two cases. Case one is when x is equal to -5. So now case one. Okay, that's when, actually, to save space, I probably need to do this. When x is equal to -5. Okay, let's see what happens. Let's look at the series when x is equal to -5. So if we plug -5 back in here, then our series becomes, we have this. -1 to the n. And then let's think about this. When you plug the -5 back in here, -5 plus 3, which is -2, to the n. And then in the denominator, we have just the same stuff. So now let's do a little bit of the simplifying right here. 2 to the n over. Okay, so we have -1 to the n times -2 to the n, then we get just 2 to the n. And then in the denominator, we just copy, right? It's the same stuff. You see what's going on here? We can actually cancel the 2 to the n. So, which is 1 over n to the 2 over 3. And we're actually getting a p series right here, where p is what? 2 over 3, right? So this series is divergent. It's divergent. Why is it divergent? Because p is equal to what? 2 over 3. So I'm highlighting the result over there. So this series is divergent. Okay, now let's test the other endpoint that we have here. So second case is when x is equal to, so that's when x is equal to what? Let me see. So that's equal to -1. What happens? Then our series, then this time that means we are going to do what? We are going to plug the -1 in there. So we get -1 to the n, and then we have, let's see what we are getting in there. So plug the -1 into this x right here. We get -1 plus 3, 3 minus 1, which is 2. So we get the 2 here. And then the bottom is stays the same, right? So now we do a little bit of the simplifying here. We can see that, okay, so we can cancel out the 2 to the n, 2 to the n, we can cancel them. And then we are going to get what? We are going to be getting -1 to the n divided by n to the 2 over 3. which is actually an alternating series. And by the alternating series test, you can actually go through all those steps, right? By checking that this is the limit of 1 over n to the 2 over 3 is approaching 0. This is 1 over n to the 2 over 3 is decreasing. And yeah, and this is an alternating series. So this is actually convergent. So we have this series, which is convergent by the AST. And so now we can actually write down our interval of convergence here. We already obtained the interval, we're checking the endpoints by doing all this work. So now we can say, so the interval of convergence is now, because we have, when x is equal to -5, the series is divergent. So we are not including the -5. So we are going to have parentheses right here that indicates that we are not including that endpoint. So the -5 goes right here. Okay, comma. And now, because when x is equal to -1, we are getting an alternating series that's convergent. And so we are getting 1 right here. And then this time we got to use bracket because it's convergent. Okay. And then you may say, now we also need to find the radius of convergence, right? How do we find that? Once you have the interval of convergence, then finding the radius convergence is also easy. If you just think of it as a series with the center at -3, right? At x equals -3, because what is the center for the series? It's whatever that's making this x plus 3 equal to 0. So x must be -3 in this case. So let's just draw a lumber line and help yourself, but you actually don't really need to. There is an even easier way to tell what the radius of convergence is. But I want to explain some details right here. So that's why I'm skipping that at the beginning. We could have found the radius of convergence long time ago when we get to this step right here, but then I'm just waiting. Okay, so now let me just show you some details right here. So let's say we have the lumber line, and then if we plot the numbers on there, if we plot the center on there, then we have -3 right here. Is that okay so far? The -3 is the center. Now, what is our interval of convergence? We have -5 and 1, so we have -5, and then the 1. Just imagine that this is actually the center of a circle. Then if you imagine that that's actually a circle that we are getting right here, then what is our radius? Think about this. What is our radius right here? That's the center. The 1 and the -5 are both on the circumference of the circle. Then you can see that the distance between, oh, it's actually -1, so I don't know why I just keep putting the 1 in there. So that's -1. Well, actually, the answer is wrong, right? So that should be -1 right here. Okay. Now, oh, by doing this, you can actually help yourself checking the answer. Let's say when I write something wrong, I realize that, okay, so it cannot be true, right? So do you see what's going on here? There are 2 units away from the center to the -1 and also 2 units away from the center to the -5. So you know that the radius of convergence is 2 in this picture. Okay. And actually, let me zoom out this picture because I need more space right here. So we'll just put it right here so that you can still see it. A nice tiny picture on there. Okay, so the radius of convergence is r equals what? It's just 2. Okay. Now, and I also mentioned that there was a even faster way without drawing this picture to figure out the radius of convergence. How can you tell? Do you see the 2 can be found anywhere? You can actually see that that's right here. So that's our r. Okay, so that's the radius of convergence. Okay, so let me just put that right here, just a note for you to remember this. So this one is r equals 2, so that's our radius of convergence. We could have stated the answer right here at this point. Okay, yeah, so that's that. And usually it's really just the interval convergence that requires more work, because when you're at the endpoint, the ratio test does not give us any information about the convergence of the series. So we actually need to plug those two numbers in and then test each series and see. But usually, if you have mastered all the series tests, then doing this could be really quick. Okay, so that's it for this problem. Thank you for watching this whole video. If you like my video, please subscribe and help me. I will post more math videos in the future. Thank you. I will see you next